Welcome to today's deep dive. Imagine you're watching a live 8K broadcast of a massive stadium concert. The pyrotechnics go off, the crowd roars, and then just dead silence.
Oh man, just the absolute worst nightmare for a production crew.
Right, totally.
Yeah.
And the audio completely drops out because, a single analog copper wire got kinked backstage somewhere.
Yeah, it happens way more than you'd think.
Well, today we're looking at the invisible tech that prevents that exact nightmare. We are digging into this massive catalog from HDTVSupply. I mean, thousands of audio and video switchers.
Huge catalog, yeah.
Yeah, but our mission today is to just cut through all that and extract the core capabilities of one highly specialized device. It's the Turtle AV TAV-DOWNTOWN Multichannel Dolby Atmos and DTSX to Dante encoder.
Which is, quite the name for just a single box. But this piece of hardware solves one of the biggest logistical headaches in modern AV environments.
Okay, let's unpack this. Think of this device like a master translator at the United Nations, but on a mechanical level.
Oh, I like that.
So you have these incredibly dense, complex audio languages flying in. And this box catches them, deciphers the spatial data, and perfectly packages them so your network knows exactly where every single sound belongs.
And what's fascinating here is how it actually does that packaging. Its core superpower is taking intricate surround sound formats like Dolby Atmos and DTSX and converting them into independent Dante channels.
Wait, let's pause on Dante for a second.
Yeah.
We hear that term a lot, but fundamentally...
Right, it's everywhere right now.
Yeah, it's basically a protocol for sending high-quality, uncompressed audio over a standard computer network. So instead of running miles of heavy, fragile copper wire, you route it digitally.
Exactly.
It's kind of like a digital post office. It takes these massive, oddly shaped sound wave packages, flattens them into uniform data packets, and just zips them down as standard Ethernet mail route.
And once they are flat data packets on a network, you have total routing flexibility. But, to get to that point, the encoder has to decode a massive variety of inputs. The spec sheet lists Dolby Digital, DD+, DTS Digital Surround, and then all these highly specific PCM configurations like 9.1, 7.1.2.
Oh, wow.
Yeah, all the way down to 7.1, 5.1, and even just a basic 2.0 stereo setup.
Let's translate that jargon real quick, because when we say 7.1.2, we aren't just reading random numbers, right? That point 2 is actually crucial.
Oh, absolutely.
It represents the overhead height channels in a Dolby Atmos setup. So this box is taking literal 3D spatial math, like the sound of a helicopter flying directly over your head, and breaking it down into distinct network streams.
Without losing any of that spatial positioning, which is incredible. And it handles the inputs for those 3D soundscapes just as flexibly. It uses standard optical audio, but also ARC and ERC.
Right, and ERC stands for Enhanced Audio Return Channel.
Exactly. It allows the absolute highest quality uncompressed audio to flow back from a display to this encoder over the exact same HDMI cable that initially sent the video.
So it just simplifies the physical wiring dramatically.
It really does.
But wait, I'm looking at the specs, and, well, I'm genuinely confused here. If this is primarily a master audio router, if it's strictly stripping out audio to send over a Dante network, why does it feature HDMI ports that support up to 8K 60 video?
That's a really good question.
Because doesn't the video just kind of hit a dead end? That feels like massive overkill for an audio routing box.
Well, if we connect this to the bigger picture, you have to think about the physical reality of where this device actually sits in a broadcast rack.
Right.
It is directly in the middle of these high-pressure visual workflows. It doesn't actually process the video. It just acts as a pass-through.
Ah, I see. So it reads the audio data it needs and then just lets the massive 8K video signal flow right through it, totally unvetched.
You got it. Passing through pristine 8K video at 60 frames per second ensures that your audio routing doesn't accidentally bottleneck your visual standard.
Right. That makes total sense.
Because if you want world-class audio, you definitely can't have the audio extractor degrading the ultra-high-definition video passing through the exact same signal chain.
So it's essentially built for the battlefield, like ruggedized for live production environments. It manages the video flawlessly so the audio can be isolated and routed.
And that overarching need for reliability brings up the most critical spec listed in the source. This device features built-in redundancies.
Which is so huge.
Oh, yeah. In a live environment, a single point of failure means the whole broadcast goes dark. If a primary network port fails or a power supply blips, the redundant systems instantly take over.
Just a seamless failover.
Right, and that seamless failover is exactly what makes it ultra-reliable in broadcast applications.
So what does this all mean for you listening at home? Whether you are prepping to wire a massive commercial venue, or you're just curious about how modern live broadcasts avoid technical meltdowns on live TV, understanding a device like this really pulls back the curtain.
Yeah, it really does.
It proves that mastering information overload requires flexible, ultra-reliable routing.
And I want to leave you with a final provocative thought to explore on your own.
Let's hear it.
If a single box can reliably untangle and independently route a massive 9.1 immersive audio stream over an IP network without skipping a single beat, how might audio over IP technology completely decentralize and reshape how live entertainment venues are physically built in the future?